mean, we've already recorded this. So I forgot to start the recording. We reflected over the y-axis. We said the y-axis then becomes our mirror line. That's why I had this really dark red line. I'm sorry, the line of reflection. That's the line of reflection. We said we need to create 3 points on the other side. So if this is the pre-image, these are vocabulary words you need to know, those of you that were gone. Pre-image is the original image. If we want to create an image on the other side, we just need 3 points that are the same distance away from the line of reflection. So point A is 1 away, just like A prime is 1 away. B is 2 away from the line of reflection. Well, B prime is also 2 away. So that's how we created those points. We just made sure they were the same distance away from the line of reflection as the original points were. If the line of reflection would have been the x-axis, if I said reflect it over the x-axis, then we would have made the line of reflection the x-axis. Could have drawn that in really, really dark. Oh, one thing I didn't tell you that I'll go over quickly. When I had this image here, if you'll notice, the y values didn't change. If you flip over the y-axis, the y values will always be the same. This point was a y value of 3. It's still a y value of 3 for A prime. B was a y value of +1. B prime is a y value of +1. Same thing for C. It was a +1. It's still a +1. The only thing that changed is all my x values just became the opposite. So that's really the formula right there. When you flip it over the y-axis, you just change all the x values to the opposite sign. Doesn't mean make them negative. This means make them the opposite. So this doesn't mean make everything negative. It means flip the sign. You need to remember that if you're going to use the formulas. A negative sign means flip the sign. Don't just make everything negative. And if you'll notice all the x values, it was +2, then it became -2. It was +5, then it became -5. But if we would have started over here and my original point was -5, it becomes +5. That's why I say don't just change everything to negative. You have to flip the sign of the x value. If you're flipping it over the y-axis. If we flip it over the x-axis, it's the opposite. The x values stay the same. So if I were to flip this over down here, I would have a point here. Oh, well, that's not right. Point here, a point here, and then a point here. And if you'll notice in that case, so that's flipping it over the x-axis, the green. The x values stay the same, but I change the y values to the opposite. So we're going to learn how to create the formulas ourselves for reflections and rotations tomorrow when we have more time. I mean, you can, if you think you can memorize, it's probably 6 different formulas, maybe 5. You think you can memorize them and get them all straight for rotations and reflections, then that's up to you. But I'm going to show you how to create it by just kind of figuring out what you did with one point and then applying it to every other point. That's tomorrow. Any questions on that? Or we do rotations real quick, and then you'll have 15, I think the last class has 15 minutes practice. Just rotation. I mean, you can practice reflections too if you want. All right, so rotations. You don't have this graph, so there's only a couple of notes you'll really take, and then you're going to practice, and then we'll do a little more detail, maybe a few more notes tomorrow. So with a rotation, here's the first thing you need to understand. You have a 90-degree rotation, a 180, and that's really it. Technically, you could have a 270-degree rotation, but I'm going to show you that's really the same thing as 90 degrees. The only thing that changes is the direction. So now, in addition to the numbers, you're going to have a direction. So it's either going to be counterclockwise. And I think that's the default for some reason. So counterclockwise, or they're going to tell you clockwise. My board is not writing where I want it to write. So you're either going to be rotating counterclockwise or clockwise. If I tell you to rotate it counterclockwise, which direction is that? Oh, I hope nobody's looking at their phone. I got mad at last class. Because the people that were looking at it were the ones that were failing the class. That really mattered. What direction would counterclockwise be? How do you figure it out? I would look at that red hand. What I would look at. Well, that's what I was hoping somebody would say. You cannot say left or right because it depends on where the starting image is. Yes, sir. So you need to look at that hand and you need to say, well, if that hand is going that way, that's clockwise. The way that the red hand goes is clockwise. So then reverse it. Counterclockwise is the other way. The reason you can't say left or right is because if the figure starts here, then yeah, counterclockwise is this way. That's counterclockwise. But if the figure starts down here, then clockwise is to the right. If it starts here, counterclockwise is to the right. If it starts here, counterclockwise is actually up. If it starts here, it's actually down. So you can't say left, right, up, or down. You have to imagine the direction that hand is going. And then again, if it's clockwise, you go that same direction. If it's counterclockwise, you go the opposite direction. So for an image starting here, if I say counterclockwise, again, clockwise would be that direction. Well, then counterclockwise would be rotating around that direction. And then depending on what number I give you, that tells you how far it rotates. All right, so that's the first thing you need to understand, how to figure out clockwise or counterclockwise. All of that. Here's the next thing. So now if I tell you 90 degrees counterclockwise, what does that mean is going to happen? You think 90 degrees means? Well, regardless, it's not good. Because either you're not taking notes at all or you're taking them in chart. Neither one. Again, there's pencils up there in that tray. What does 90 degrees mean, do you think, relative to a graph with 4 quadrants? Well, 90 degrees is a right angle, but when we're rotating something 90 degrees, it means something else. Tell me where you think that triangle is going to go. It's 90 degrees. So if I say 90 degrees, I'm also, by the way, I'm going to use these abbreviations. I'm going to get rid of this stuff in a minute. So that is counterclockwise. That's going to be clockwise. I'm not going to write those words all the way out, really, from now on. So if I just write CW, that means clockwise, right? CCW, that means counterclockwise. So if I tell you to rotate that figure 90 degrees counterclockwise, and you tell me something about what's going to happen to that figure. All done. Certainly in pre-algebra you did. I think in algebra. What do you think? Ooh, we have a lot of work to do. 90 degrees is a quarter of a turn, right? Because it's 1/4 of 360. Circle is 360. 90 degrees is 1/4. So that means it's going to move from here. Counterclockwise means opposite direction of the red hand. So that image will move from this quadrant into this quadrant. And I'm about to get rid of a lot of those words. So if it was 180, it's always directly across from where it starts, because it would move, anytime you move twice, you're going to be in the opposite quadrant. So 180 will off. So if I started here, 180 would put it down here. But here's the other thing you have to understand. The figure itself is also rotating. So not only, and now I'm going to get rid of some, actually, I'm going to get rid of all of the words. So if I'm doing 90 degrees counterclockwise, the figure moves into the quadrant on the left, but it also rotates 1/4 turn. So this C, and I'm not even going to draw the figure in yet. I'm just going to know, well, if this C is here, and if it rotates 1/4 turn, C is going to wind up somewhere up here. Well, if B starts here and I turn it like that, B's got to be somewhere down here. And if A starts here and I turned it, this side would basically be the bottom. So A would be somewhere over here on the left. So my new image is going to be something like that, even if I don't know exactly where the points are yet. That's the first thing I want you to be able to visualize, because here's the deal. Let's say you try to memorize stuff and you forget it for mostly not my test, but for the district test. I don't know about the district test, but probably the state test. It's going to be a lot of multiple choice. If you just understand that C is now on the top, B is on the right, A is on the left, if you understand this figure moves from here to there, even if you can't draw it in the correct spot, in multiple choice, I guarantee you can probably figure out the correct answer from just knowing that right there. Just knowing it's in this quadrant, C is at the top, A is on the left, B is on the right. I would be shocked if it didn't at least eliminate a couple of answers, but I'll bet you the other answers they give you are going to be like down here or over here, or maybe they put it here, but they don't twist the figure itself. So I think in multiple choice, if you can just understand that the image goes from here to here and that it turns upright, like C being at the top and then these being the bottom now, I think that's probably going to get you an answer most of the time. What if I would have said 90 degrees clockwise? Where would it go? Yeah, so clockwise, again, imagine which way it goes. So clockwise would have been this way. So 90 degrees is one turn, but now the A, B, and C are going to be in a different orientation. C is also going to turn down one. So C would actually be on the bottom left now, so somewhere around here. So if I again turn it, then that means B is on the upper left now. So B is going to be somewhere in here. A turns to the right. It's going to be somewhere in here. So something like that if it went clockwise 90 degrees. Even if I don't know where they go, again, I'll bet you that would probably give you the answer. If you just understood that the shape turns or moves one quadrant for 90 degrees, and then the shape itself turns 90 degrees, which makes this now the bottom left, this the left top, and then A the right top. And then, like we said, 180 will always be over here. You have to imagine it turning one more time. It does not matter which direction you go for 180 degrees. So it doesn't matter if they say 180 degrees clockwise or counterclockwise, it's going to be in the same spot. If I turn, and I'll just show you this. So let's say I took the red image, and let's say I turn it one more time, one more 90-degree turn. Well, where is the C going to go if I do one more 90 degrees counterclockwise from here, even without drawing the figure in? Where is C going to go? Well, what quadrant first? Let's say that. If I'm going 90 degrees, so I started here, I'm going to go 180 degrees. So I go 90, and then I'm going to go 90 again. So it's going to be down here, right? 90 and then 90. So where is the C going to go from here if it rotates one more time, spins? Wouldn't be all the way down, because that would be like flipping it twice. So if I just rotate it one, it's going to like fall to the left, basically. So where would C be? What do you think? Where would C be? Yeah, it's to the left. Is it going to be on the top left or bottom left of the new figure? It's going to be top, right? If you aren't seeing that, then this is going to be a little trickier lesson for you, like a little trickier topic. If I just think about this, it's kind of a triangle. I don't know exactly where everything is, but if it turns one more time to the left, C would fall down and be to the top left, somewhere over here. Well, if C falls down, B has to then rotate up with C. You'll notice B and C are always going to be in a straight line. So that's kind of another thing that I know. B and C are in a straight line here. They're in a straight line here. They got to be in a straight line here. Now A then, if I turn one more time, it comes down and rotates around to the right. So something like that. Now, if I thought about doing one more rotation clockwise, you'll notice it's in the same spots. C would rotate around and up. B would rotate over and right, so it would be there. A would rotate down to right where it was. So it'd be the same thing. Doesn't matter which way we go for 180 degrees, clockwise or counterclockwise. Either way, we arrive in C, A, and B in those particular positions. All right, so here now, oh, by the way, this is around the origin. I didn't emphasize that. You've got to understand everything we're doing right now is around the origin. I'm rotating around the middle point of this graph. There are problems where they will tell you to rotate it around some other point, and those are much trickier. I don't even think I'm going to quiz you on those. I'm going to show that to you probably at some point before the lesson is like this topic is over. It's not going to be on my quiz though, just because they take a lot of time, and I'd rather you focus on the problems you're going to see more often instead of spending a whole bunch of time on one problem. Oh, so here's the other thing I was going to tell you. If I then, let's say I rotated this one more time even. So let's say instead of rotating this figure 90 degrees counterclockwise, I'm going to rotate it 270 degrees. So I already did 180. That was this figure. I'm going to do it one more time, which would be 270 degrees. And I'm still thinking about this one as the original. So that'd be 90, 180, and I'm going to rotate it one more time. Well, if you'll notice, C is now going to drop down and be kind of the bottom left. Well, that's where it is here already. A is going to move up to the right. Well, that's where it is already. B is going to just kind of be the top left now. That's where it is already. So here's your note to take. 90 degrees counterclockwise. I'm sorry, scratch that. 270 degrees counterclockwise is the same thing as 90 degrees clockwise. So you won't really see formulas for anything with 270 degrees. Because all you got to do is just say, oh, well, I know 270 degrees counterclockwise is the same thing as 90 degrees clockwise. 270 degrees clockwise is the same thing as 90 degrees counterclockwise, because I would go 1, 2, 3, which would be the same thing as just going 90 degrees counter. So you really won't see form. I mean, they do put them on some sheets, but they just say it's the same thing as this is the same thing as this. And then this would be the same thing as 270 degrees clockwise. So just understand that the way that it rotates around the origin is 3 rotations is the same way as 1 rotation in the opposite direction. I think that's. Oh, we didn't put the actual points. So now let's do the actual points. So I'm going to get rid. Is anybody still writing? I'm going to get rid of all of that. Still writing? Or? Yeah. So starting from which image? Tell me which image we're starting. Upper right, upper left, bottom right. All right, so what was your question again then, now that I know what you're talking about? Well, we're not flipping it. That would be a reflection. We're rotating it. Okay, now when we get into more complex stuff, you're going to do more than one transformation to a figure sometimes. Like they may say, what 2 transformations can you use to match image 1 or the pre-image onto the image? Sometimes there's more than one answer. Like you might be able to flip it and get the same answer. Sometimes flipping it is the same thing as rotating it, depending on how far you rotate it and all that. So sometimes there are multiple things you can do, but I don't know when we'll get into that. I don't know if we'll get into that this week or not. I have to look at the calendar and see how much time they give us to work on this. I don't know if this is a 2-week lesson or a 1-week. If it's a 1-week lesson, we might have to do it this week. Go ahead. Oh, let's do the points then. So here's the next thing I'm going to tell you. Now that you kind of hopefully are maybe catching on a little bit, if I understand that 90 degrees, I'm going to go clockwise this time. I think for some reason, I think counterclockwise is easier to see for this image at least. I want to say, okay, where is that image going to go if I go 90 degrees clockwise? It's going to be bottom right because it's going to go clockwise once, which means it's going to drop down and it's going to rotate. Here's the key though, or not the key, but here's the trick. A 90, oh man, I got to zoom out even more. If we are doing rotations around an origin, it's the same exact thing. Hold on. It's the same exact thing as spinning the whole entire graph, image and all. Like literally, you take your paper, which unfortunately a lot of your equipment is on computer, like when you do the district stuff and the state stuff. If I just took this whole graph and just spun it one time, if I just spun it 90 degrees counterclockwise, again, that's 1/4 turn, 90 degrees is a quarter of a circle. If I just took this and said, well, I'm just going to rotate it 1/4 turn, that's where the image is going to be. If you visually can see that, like if you're kind of a visual person, then you just would say, okay, well, I'm going to just think about rotating the whole entire graph. A lot of teachers give you like tracing paper and stuff. I don't do that because I'm like, well, you're not going to have tracing paper on quizzes or anything. I'm not going to give it to you. I don't know if they give it to them. But if you can just think about turning that whole image, that's your new figure. That's it. The C point is at top, like we said it would. The B winds up being like if I turn this whole thing, the B is going to be lower right. The A is going to turn and be lower left, just like it is right there. The points are all exactly where they should be. So this point here, or these points, I should say, A, B, C, which were what? 1, 3, 2, 1, and 5, 1. Move. That's a prime. I don't know why I made such a long mark. So now that moves to, so A is now negative. You have to treat this now like it's the x-axis and this is the y-axis. So A is now -3, 1. B is now -1, 2. And C is now -1, 5. There's your new points. Just rotate the whole graphic. You're very visual. When this will work, tomorrow I'm going to show you how to create a formula instead of memorizing it. You can memorize it if you think you can get all of them straight. But basically, if I understand how to create one point from the figure, I can use what I did with that one point, and I can come up with the formula I need to do the rest of the points. Well, I did a 90 degrees clockwise. Oh, actually, I did counterclockwise. Sorry. I said clockwise, and then I still wound up doing it. So that's actually counterclockwise. I meant to do it. Oh, I just did it for you. Well, let's do clockwise. So now we'll go back. So now imagine rotating. So I'm going to put this back to the original image. Now imagine rotating the whole figure and now do 90 degrees clockwise. I just did counterclockwise. You try to imagine where clockwise would be. I'll give you a hint. If you have a line here that is only one like unit away from this axis, when you rotate it down, it's only going to be 1 unit away from this axis, right? Because if I rotated this whole thing, this doesn't get any farther away from the axis. It just moves down with the axis. So it's going to be 1 unit away on the left. If it's 3 units long, it's still going to be 3 units long down here. So some of those things don't change, and you can kind of use that to figure out where it goes. Try to, I'll tell you the original points if that helps you if you're going to draw your own graph. So the original A is 1, 3. The original B is 2, 1, and the original C. So that's the original points. You tell me the new points if you can come up with them. Again, if you want to draw your own graph real quick and turn it, it doesn't have to be perfect for that to still work. Nope, because you're not going to be able to do that on quizzes or anything. I want you to be able, whatever you're going to have to do on my quizzes, and more importantly, the district stuff and the state stuff, I want you to be able to do that right now. certainly work. That's why I don't give tracing paper out. Yeah, tracing paper worked great. Get tracing paper on the Facebook stuff or on the states. That's what other teachers do. Is they give you little patty paper tracing. I mean, I'm not saying we will never use it. I might. What's that? I want you to use this information here because sometimes they're not going to give you a graph. That's the other thing. They're just going to say, take these 3 points and rotate that triangle 90 degrees counterclockwise. And they won't give you a graph at all. So you'll have to create your own graph if you do it that way. And again, I'll show you the formula way tomorrow. Well, maybe I'll do it. I'll show you how I would do it really quickly. Because if you can imagine, like if you're really visual, if you can just imagine that whole graph spinning 1 rotation counterclockwise, you just spin the image, the graph, everything. I think you can, I mean, this is a pretty easy one to put it out. If you can't figure this one out visually, then you're going to struggle a little bit because this one's not a real difficult one to figure out visually. Raise your hand if you're done. I got a lot of people not doing it. Yeah, that was one. Are you done, Jessica? I need 3 coordinates. I don't just draw a new image. You need to give me 3 coordinates, A prime, B prime, C prime, that all have an X and a Y value. Other 10, 20, 30 seconds. At least, hopefully, you can get, if you can get 1 point right, you should be able to get them all right. All right, so you have to be honest with me right here. A lot of you didn't try it. You tried it. Who thinks they got it right? Raise your hand if you're like, yeah, I got it. I see exactly where it is. Because if you're not visual, this is tough. If you're visual, then this is, you may look at it and go, wow, this is super simple. So raise them high so I can see. 1, not sure. Finish fast. Okay. All right, so we got 4 or 5. So that's not bad. That's not, some of you didn't try it. So I don't know if that's because you thought it was too easy or you didn't know what to do. Again, I want to think about rotating this whole image 1 quarter turn clockwise. Where is the new image going to be? So if this is the image starting, where is it going to be? Like what quadrant? Left, right, across, below, like just describe it words. Sure. So hopefully you're getting that part. If you're struggling with that part, then that's just a definition. If I'm rotating at 90 degrees counterclockwise, it moves 1 quadrant in the same direction as that second hand. That's clockwise. So the second hand's going that way. I need to move it 1 quadrant, which in this case is down. So that's the first thing you should definitely know. It's going to be down here. That'll probably eliminate 1 answer on a multiple choice test for the district or the state. I think. Could be wrong. Now I need to imagine, well, how is the image itself going to spin? I know it's going to be down here, but it's going to spin also. What's the bottom of what point is going to be on the bottom? How it spins? 1 turn, 90 degrees. C will be on the bottom. Good. So if you're picking up on even these few things, even if you're shaky on the numbers, C is going to be somewhere down here. Because if I take that image and I turn it 1 quarter turn, C winds up going from the right down to the bottom. What's going to be the top 2 points then? Only 2 left. Going to be 2, well, A would truly be top, but A and B will be right. If this is down below, A and B are going to be up at the top, right? Which one's going to be on the left, A or B? Jake, which one's going to be? So A and B are going to be on the top part of it. Which one's going to be on the left out of A and B? Well, no, between A and B, which one's going to be left of each other? One of those, so I've got 2 points, A and B are up top. Is A going to be the left point of those two, or B going to be the left point of those two? B is, right? If I turn this down, B just kind of swings down to right there. That's where B is going to swing. A is the one that kind of swings all the way out here. That's what turning that image looks like. And again, I'm just thinking about all this in my head. I'm going to turn the whole image for you in a second. So I know, again, I can't really erase everything, so let's just erase that. I know it's going to be something like this. Again, if you're seeing that, I think that'll get you through a lot of the district and state stuff. Now you just have to figure out where are the points. Well, I know this line right here, if the whole thing rotates, it's got to be right next, not on the axis, but it's got to be right along the axis, right? Because it's along the axis here. So if I rotate everything, it's still got to be along the axis. It's just straight up and down now. If that's the case, the numbers don't change. I'm going to go from 5 to 2. So that's where my points would be. I didn't slide the image around, so if this point here matches up with 5, and if this matches up with 2, they should still match up with 5 and 2 here. Because there's no sliding going on. There's no translation going on. Well, if that's the case, I got to just figure out where A is. Well, A is only 1 away from this axis, and it's on 3, so I would need it to be 1 away from the axis. Again, the numbers don't change. Didn't slide the figure around, we just spun the whole graph around. So if it was on 3 here, when I rotate it, it's still going to be, it's 1 away from 3 technically. So 1 away from 3. And that makes sense because from B to A, I go over kind of and closer. So I go over and closer to the axis. I'm going to give you a way to come up with the actual numbers tomorrow. Also, for now, go ahead. You don't have a bunch of time. If you want to practice it, you got 8 minutes. Yeah, go ahead. You should be able to practice it. That's kind of like it's 3 minutes. So here are the ones I want you to try. One of these 4. I don't care which one. So go ahead, log in. Don't be lazy. Again, we got still a lot of stuff that I may have to get through. I haven't really. There's one very challenging. Well, it's not very challenging, but you have to do multiple transformations in one problem. So not just a rotation, but you might have to do a rotation and a reflection. And you have to come up with which ones you should do by just looking at 2 images. You have to be able to say, oh, well, if I reflected that, and then if I rotated it, it would map it onto the other image. That's probably the trickiest part. Oh, I didn't write the coordinates. So it would be A would be 3, -1. B would be 1, -2. C would be 1. You'll notice the numbers don't change. I still have 1, 2, and 5. Well, they're the opposite versions, I guess. So the number part didn't change. 1, 2, and 5, 1, 2, and 5. 3, 1, and 1, 3, 1, and 1. So that's what we're going to use tomorrow.
When I did it, when I flipped it the whole thing, because I did like the Y part, just the Y's.
Well, we're going to come up with a way to do the formula tomorrow, but for now, just when you create the new image, if you're rotating around the origin, the numbers should always be the same numbers. You might have an opposite version that might go from positive to negative or negative to positive, but you should never have a totally different number show up from these 6. Like a 4 shouldn't pop up, or a 6, or any of that. Like you should always have, and it should be the same combination: 1 and 5, 1 and 5, 2 and 1, 2 and 1, 3 and 1, 3 and 1. It's just one of those is going to become negative, and they're going to change places. If you'll notice, the Y values become the X values down here, and the X values become the Y values, and then we also change the sign of the X value. That's why I say memorizing formulas is going to be a little tricky. Just feel like you're going to confuse them a little bit, especially for the district and state stuff, which are going to be twice down here. What's that?
A square.
Oh, that's is it a rotation? Are you doing rotations? Yeah, they may give you figures that are not triangles. So it's the same concept though. You're just thinking about every point individually. If you rotated the whole entire graph, square is actually a lot easier. That's true. Oh, yeah, then that's again, you have to think about two rotations. There's a now I will say a 180-degree rotation, there's a pretty easy shortcut. I probably will just, I'm gonna give you the formulas for all of them. I don't think you can memorize. Maybe. I'm just not big on memorizing.
Fine.
I'm gonna start taking. Yeah, you've been on it multiple times. Don't act like that was. Guys that are on your phones constantly sneaking peeks. Not just this class. Did I go over the tutoring? I didn't go over the tutoring yet, did I? I'm doing tutoring on Wednesday, but since my tutorings got canceled last week, I'm going to drop the requirement, the retake requirement of doing a tutoring session. But I'm still leaving that deadline for the 7th. I'm not changing that just because we had 4 days off, but I am going to get rid of the tutoring requirement. So you had IXL at home. Some of you may not have had power for a little bit, but most of you did. And you still have all week this week to get IXLs done. So come the 7th, you haven't done your retake, grade is your grade. Unless maybe you were like missed a whole bunch of school for other reasons or something. I might talk to you individually about that. But for most of you, you've had all quarter. I'm not going to be sitting there grading 100 retakes over the weekend right before grades are due because you guys waited. I don't know. I know what a lot of you are thinking, because there are a lot of low grades, so not sure when you were planning on coming in and making stuff up, but you got 5 days. Kind of the time. So all you have to show me for retakes really now, and I'm gonna get more quizzes back tomorrow. You need to show me your quiz corrections and your IXL score, or if you just tell me which one you're taking, I can look your IXL score up, but. All right, wow. Oh, that's right, we get out a minute earlier. I'm sorry, I thought we got out 11:40. Let's get out at the same time. Oh, no, 4:30. All right, I'll see you guys tomorrow. Yeah, I'll be surprised. Green Day, huh? That is vintage. Vintage music. Who is coming in to do a makeup today? Rated average. Angel said he got his birthday gift. Well, he said you told him about it. I don't know if he got it or not. Oh, did you? I said, did she tell you that I gave her your birthday gift? And he laughed. He said, yeah. Oh, man.